Okay, so you probably saw this lion in the grass instantly. And that's because your remote ancestors were able to observe the world, see dangers in it, and act on it really, really quickly. What I'm going to talk about today is the fact that humans, all humans, are able to really take advantage of data because of our innate abilities. Like, for example, that ability to be able to notice dangers in the world. My name is Jock McKinley. I'm the Vice President of Research and Experience at Tableau Software. I've been at Tableau since 2004. I joined Tableau out of the research world. I was at Xerox Palo Alto Research Center, and before that at Stanford University. And so I know a lot about visual analytics and human-computer interaction. And this amazing capability that we've inherited from our ancestors also causes a problem for us, which is that our ability to really rapidly leap to conclusions and decision-making also leads to bias. And the problem of bias is that you could leap to the wrong decision. And one of the biases, there are a whole bunch of them, is called confirmation bias. And confirmation bias is confirming your intuition about what the right answer is. And it turns out confirmation bias in particular, the smarter you are, the more you are able to come up with arguments for your intuition. In other words, the smarter you are, the more in danger you are of falling for confirmation bias. Now, I have a really very visual example of bias that comes actually out of the fundamental research that when they were studying people with respect to bias, that I can just take you through so you can just experience it yourself. And it goes like this. Here's a baseball and a bat. And together, I'm going to tell you they cost $1.10. And the bat costs $1 more than the ball. And the question is, how much does the ball cost? Likely, many people in the room leapt to 10 cents. But that's actually wrong. The right answer is 5, because if you do the math, you'll find out that that is what leads to the right answer. It's that leaping to the wrong answer is an example of a bias. And what's fun about this particular example is you can literally see the value of data and data computation with respect to sort of dealing with bias of one type or another. Once you had that intuition and leapt to some answer, you can then use data to check to see if you're right or to see if you're wrong. And then, of course, you can fix what you want to do. However, there's a problem with using data, which is that people aren't very good at using data. So here's a standard 2x2 multiplication problem. And one of the realities of how the human brain works is we have limited short-term memory. We have trouble holding those partial results that you need to have to be able to compute this multiplication problem. But humans have evolved to use the external world to help them think. And if I said you can use a pencil and paper to hold those partial results out in the world, you can work this problem quite quickly. In fact, if you run subjects against it, 5 times faster than trying to do it with mental math because of all the partial results you have to hold in your world. So that's sort of the core of the Zen of visual analysis. We're trying to provide an external environment to help you effectively work with data of one type or another. And so we know a lot about how humans work, and we can take advantage of that. I'm going to give you another nice visual example, since we're right around lunchtime. I want to wake you up, about how we use the external world. And it's a psychological phenomenon called change blindness. And what I'm going to do is I'm going to show you a video of this picture, and then there will be a little bit of gray, and then the picture will come back. Between the two pictures, something is changing in the picture. And the gray is actually really important. Now, our visual cortex is really powerful. The gray is to decay the image on the visual cortex. And you will have trouble seeing the change. So here's the movie. If I fire it up, you can see the gray. And I know exactly what's changing in the scene, so I'll put my hand up. Please put your hand up and keep it up until I'm going to wait for at least half the room. Some people saw it really quickly. Their eyes happened to follow on just the right spot at the right time. But if you scan around, you'll be able to see what's changing in the environment. And it looks like we're getting to about half the room. I don't have a point. Well, actually, I do have a pointer here. I just forgot I have my thing here. I think I can point. Well, I'm going to not run the risk of it. It's in the upper left-hand corner of the boat. There's this ice chest on the side of the boat. That's what's changing in the environment. Now, the decay is actually really important. I have another example of another video. This has no gray. Your visual system's actually really, really good at picking out changes like this. This is why we can see the lion in the grass. We have really powerful visual system for that. But you can just see how much we use the external world. I should stop this video. Thank you. You can see how much we use the external world in working with it. So, more along those lines. There are other aspects of how our brain works that we can take advantage of. So here's a large grid of numbers. And if I were to ask you to count the nines in this grid, you would have to scan around, find all the nines, and it would take you a really long time. But I'm about to color all the nines red. And your visual system is able to separate out objects based upon their visual attributes. And you can see you only need to attend to the red objects to count them up. And that's called perceptual popout. And this is a very powerful technique. Here's a standard crosstab that an accountant might use. And so for accountants, one of the lions in the grass for accountants is negative numbers. They want to go investigate them to find out what the heck is going on. And accountants, who are not psychologists, they don't understand how the human brain works, have come up with the convention that they're going to color the negative numbers red so that they pop out of the crosstab at them so that they can go and investigate them. So that shows you how powerful we can take advantage of the various techniques that people have. And of course, what we want to do, what we can do, is we can encode the data visually. So here's a visual encoding of the same data. And to give you a sense of the power of that, in the upper left-hand corner here, we have Amaretto and Colombian. This is, by the way, the sample coffee chain data set that Taobao used to have, which I still keep alive in this talk. So in the central region, if I were to ask you, what is the relative value of Amaretto and Colombian sales? Well, the problem here is you have to do mental math. And I just told you people are really slow at mental math. But here, if you look here, you can instantly see that Amaretto's sales is half of Colombian sales, and profits encoded on color so that you can go look for negative profit and go worry about that. And so we can use all sorts of techniques like this. And furthermore, we are using computers, which means we can create really interactive experiences where you can go in and explore. For example, select a particular mark and go in and explore on that. So that process, that interactive process, we call that visual analytics. And back in the research lab, we did a lot of studies of lots of people using lots of different technologies. And we found that the standard process that people go through when they're trying to do analytics using their visual systems around data goes like this, which is you start with some task where data is relevant to it. Now, given what I said about bias, almost every task data is relevant to it if you can go get the data, and there's more and more data in the world every day that is relevant to more and more tasks. So the first thing you need to do is go get the data for your particular task. You need to choose some sort of visual encoding for the data because that's tapping the power of your visual system. View the data, develop an insight, and go off and act. Sounds simple, doesn't it? Well, the reality of it is, when you study people doing this, it's actually a really complex backtracking process shown by the arrows in here. You start with a task, you get a data, you choose a view, a mapping, you look at the view. Almost never is that view going to give you your answer. You almost always need at least another view or another view. Sometimes you look at a view and realize you don't even have the right data. And sometimes you look at a view and realize you don't even have the right task. You thought you had the task and you want to change the task. And here's what's really interesting. Even after you've gone through that process and gotten the right data, looked at the right views, and you've developed an insight, well, you need to go on, with insights, you need to go off and act on them. But we're humans, we're a cooperative species, and almost always you need to share your insight with other people. So that's why I put share in parentheses under act. And to do that sharing, you almost always need additional views to tell a story about your insight. And sometimes you need additional data to tell that story as well. So even from there, there's backtracking that goes on. Now, what I want to do is give you a real sort of visceral sense of how this process unfolds. And to do that, I want to give you all, ground you down in a particular set of data with a particular analytical task, because that's what the reality of it is. And so I have a favorite set of data I like to demo, and here's how I'm going to induce the analytical task for you, which is what happens when you have one of these and it meets one of these? Well, if you're very, very lucky, you get one of these. And of course, this is when Captain Sully hit a flock of birds and was able to land the US Airways plane on the Hudson, and all lives were saved. And so, yeah, the task is going to be, about bird strikes and how safe it is. But I actually, a couple of years ago, had a personal experience, so this is even more visceral for me. I was flying from Seattle, which is where I live, down to Texas to meet with a bunch of Tableau customers. We have great customers in Texas. And I was taking off from SeaTac on an American Airlines flight, and we'd just gotten up in the air, and the pilot came on the intercom system, and he said, I hit a bird on takeoff, and it took out my forward-facing radar, and there were other birds in the vicinity, and so I don't want to fly down to Texas without the radar, and I'm not sure the landing gear, which was still visible, might not have been hit by a bird as well. So we're going to circle for a while so the emergency vehicles can get on the runway, and then we're going to land. So we circled for a while. I was thinking about my bird strike demo, and then, we landed just fine. And this is what the plane looked like after I walked off the jetway. And the thing to know is that there's just a cowling over the front of the forward-facing radar. So it doesn't take a big bird to make a dent like that. But nevertheless, it was sobering. So have I done that? Induced a little bit of question in your hand? So what I'm going to do is I'm going to give a demo about a data set that's, when Captain Sully had a safe landing on the Hudson, somebody at Tableau went off and found out that the FAA, the US government, has a wildlife strike mitigation working group, and they're collecting reports from pilots all the time about wildlife strikes. And this is just like typical data, like data that people deal with all the time. On the left column is a date field. A lot of data sets have dates in them. Then there's string fields like airport and species, and then quantitative fields like height and speed. It's just very common data that you want to deal with. And then if you bring that data into Tableau, here's the data set over here. So you have, there's more columns than just what showed on that slide. So you have aircraft, amount of damage, there's the flight date, origin state, a bunch of other string columns, and then there are quantitative columns like the total cost, feet above ground, and then down here you have number of strikes. And in Tableau, the way you go about exploring the data is you just drag and drop. And so if I drag out the number of strikes and drop it on the column shelf, you can see that there's 260,000 reports to the FAA about wildlife strikes. And for this particular question, this amount of damage field here is probably a good one that you would naturally go for. And if you drag and drop it, then you break that line apart. And I can also take this amount of damage field and drop it on the color shelf. And so what are we seeing here? We're seeing 55,000 reports of null for damage. What null means is it's empty. So the pilot didn't even bother to mention that there was any damage, so there probably wasn't any damage. Then there's 180,000 nones, and all the way on down here to 163 planes destroyed. So what naturally happens when you start looking around at data like this is questions just pop into your head. So like, for example, here's the cost field. What's the relationship between the number of strikes and the cost? Well, you can go explore that really quickly. I can just drag the cost field up here, put it on the column shelf. I get 2 columns. This is actually a fabulous way of looking at sort of correlation. This is like inverse correlation. You don't have to know what that statistics terms means. This one's dropping, and this one's going up. And so bar charts, sorted bar charts like this are really good for that. It's not surprising the cost is going up because this is increased damage. But what was pretty surprising to me when I first looked at the wildlife strike data was how big this orange bar is. And as you can see, that right now, it's $886 million, almost $1 billion of damage. And no wonder the government can afford to have a little wildlife strike mitigation working group with those kinds of costs involved in what you're doing. So now, have I actually addressed the question, is it safe to fly? I mean, there's only 163 planes destroyed. And I hope my comments about bias have created at least a little bit of inquisitiveness in you. And this is what I recommend anytime you're exploring data, if you have a tool that allows you to explore really quickly. If you think about it, there are standard questions that we haven't really addressed yet. They're the what, where, when questions. And so it might be the case that where I live in Seattle, it's, like I had this experience with a bird strike, it might be more dangerous than just generally overall. And then there's also when questions. Maybe the trends are getting worse. And so before we actually finish and conclude that it's safe to fly, we ought to go off and explore those sorts of things as well. And so in Tableau, I'm going to keep this viz. It's a very useful one. I can just open it up an additional sheet and start going and exploring those other aspects of the question. So for a when question, here's origin state, and I can just drop origin state on the detail shelf, and I get a map. And then I can pick up the number of strikes here and drop it on the color shelf, and I get a nice filled map. And the color here is encoding the number of reports to the FAA. Lots of reports from California, because it's dark blue, from Texas and from Florida. And that makes sense if you think about it. Those are very populous states, and so there's a lot of pilots flying around. But look at Colorado here. It sort of seems darkish blue. Well, what I'll tell you as an expert is that color is actually not a great way of looking at quantitative data. But you don't have to know that expertise, because you can just go explore yourself. So like I could pick up the number of flights field here, and I can move it from color over to size. And it turns out we are really good at estimating the area of circles. And you can actually see here that there are a fair number of reports from Colorado, even though it's not a very populous state. There are not that many reports from Washington State, where I live, so probably safe to fly, at least from Washington State. And of course, we could dive in at this point and do like really deep spatial analytics of one type or another and proceed forward that way. And it is fun to do that. But I want to go on. I want to actually also check the when question. And for that, I'm just going to make another new sheet. And I'll drag out the number of strikes. And I'm going to go find the flight date field here because maybe the trends have gotten worse. And now I'm going to drop the flight date on the column shelf. And now we have a trend line. Now this is the audience participation part of my talk. There are two things here that just totally leap out instantly about this particular trend line. What are they? There's the drop at the end. What's the other one? Yeah, there's this long growth up to that point. In fact, if you look at it, it's 2 decades worth of growth. So when you see things like this, what you should do is try and figure out what might be going on. So for the drop at the end, any hypotheses about what's going on? Yeah, what? Yeah, partial data. And you can actually see this really quickly. Just by here, I can flip over to add in quarter, and I can drop down to month. And so here for 1990, you can see that there's more reports in the summertime and in the wintertime. And then you can see that's true for every month. If I scroll over to the last year, yeah, we don't have all the months there. So exactly right. And then Tableau is trying to create really interactive experiences so that you can just work with your data. If I select this point, on the tooltip on the tooltip is the ability to exclude that point. Okay, now here we have what looks like a significant trend over two decades of increase. Any hypotheses about why you would see that increase over 2 decades? More reporting from here. But that's we shouldn't just go for one hypothesis because we want to make sure that we're not doing confirmation bias. Yeah. More flights, yes. Now, there's one more that I hear that's actually really funny. Yeah. More birds, exactly, yes. Now, I actually know that, given climate change, the bird population isn't actually increasing. So I don't have a bird population data set here, or I could go explore it. But we can explore both the other hypotheses right here. And the more reporting one is darn easy because you've already seen me do it, which is just drag out the amount of damage field and drop it on the color shelf, breaking that line apart. And what you can see here is that the null is going up, the none is going up, but the minor, medium, substantial, and destroyed are staying flat. Interesting. In other words, where reporting mattered, where there was actual damage, the reporting has stayed absolutely flat. But in the other cases, the null and none, it's been going up. And here's this interesting spike here. And this, by the way, is exactly when Captain Sully had a safe landing and there was all this press about bird flights. And likely what was driving it was all that press told small plane pilots, no, they really should report to the FAA about that bird that bounced off their windshield. Now, we're not done, of course. We took one of our hypotheses and explored it. And so we should also go explore the more flights one as well, just to find out, if that one is as equally likely as this one. Now, I actually do have a flights data set here that also comes from the FAA. And so this is data they were collecting about on-time arrival statistics, and so it has these standard sort of things, destination city, flight date, origin city, and then a bunch of quantitative things like arrival delay and on like that. And so, if you drag out number of flights here and drop it on the column shelf, this is an interesting data set. This is a bigger data set than the last one. This is 168 million rows of describing commercial flights. And back, 5 years or 8 years ago, I would have had to put this data I could still do what I'm about to demo for you, but I would have had to put the data into a Microsoft SQL Server or some sort of reasonably hot computation box, because at 160 million rows, that's a lot of computation that you have to do. But we've been investing in data computation. And on this little laptop here, I have hyperrunning, which runs just fine on a laptop. And it's like just so fun for me. I can drag flight date here. When I drop it, it's going to have to scan all 168 million rows to aggregate the data up to year level, and it just, boom, does it like that. Now, we know that this is incomplete final year, so we'll just get rid of it. Now, there's a couple of things about this trend line that maybe not so much leap out at me, but that are there that are pretty obvious to a visual system. What are they? There's this dip right here, exactly, and then there's this drop starting right here. I'll give you a hint about this one. That's 2001, and so yes, this is 9/11, and then I can show you what this one is by actually. Now I'm going to re-aggregate all that data now down to the month level, and so you can see the drop for 9/11 right there. And this drop here happened August 2008. That was when Lehman went bankrupt, and this is commercial flights. And it had an immediate impact on companies sending people on business trips, essentially. And that was why the drop is that occurred after that. And companies learned how not to send as many people because the drop has stayed flat ever since then. So this is the flight data set. And so the key question for us is, what is the relationship between this data set and the strike data set? This is actually extremely common. Whenever you start doing exploration of data, you're almost always needing to combine multiple data sets together. And it can be an intellectually challenging task to do that. Down at the row level for these two data sets, they really are very different. The flights data are, planes fly every single day, so it's extremely regular, whereas strikes is extremely episodic. There may be days when there is no strike in the entire country, and other days with a whole bunch of them. So trying to merge these things at the row level is extremely difficult. But up here at the aggregated level, it's actually really easy to do that. And so we added in a real simple drag and drop ability to be able to do that. So there's flight data in play here. Both data, I just switched over the strike data set. It also has flight date. I carefully named them the same so that I wouldn't have to do that during the demo. But I can just now go down here and take the number of strikes field and drag and drop it into the view at the same time. And now we can do the visual comparison. And what you can see is, well, yes, there was this big increase here, and there's a big increase there, but over a 2-decade period, this was flat. This is the number of flights, whereas the number of strikes, probably the reporting, was going up. They don't actually really correlate with each other. So you can do this exploration thing. And for those of you in the audience who are like, making joining between data sets this easy, you're worried about that? Well, the reality of it is when you do this in a visual context and you do some join that is bad, you can very quickly see that it's bad, and you just back out and you proceed forward and you go do something else. Okay? So now, that experience, that ability to sort of just go through data really, really quickly, you might think that the value is the aha that you get. And it can be extremely valuable to have an insight based upon an experience like that. We have literally had people trial our Tableau desktop, which is what I was demoing there, get an insight during trial that's paid for all of their subsequent purchase of Tableau, which is great. And it is extremely valuable to get the insight, the aha. But the bigger value is actually the time it saves you. So when you have tools that allow you to work really rapidly with data, Projects that might have taken 6 months might only take you a month. Project that took a month might take a week. There are other tasks that you wouldn't have, with slow tools, you wouldn't have even used data for at all. You just go on your hunches. But, which is actually, I think, a comment that Adam made in the opening keynote. But now you can just sort of pick up the data and check to see if your hunch was the right thing by using data to validate it, or then realize you have to dig in a little deeper. So, how do we empower ourselves and our colleagues with respect to analyzing and sharing data? Well, the core of it is to support this cycle of visual analysis that we literally see when people are working with data in the world. And what I'm going to do for the remainder of the talk is I'm going to stop at the 3 blue parts here and argue why almost everyone in an organization can use data effectively. And this is important because, as I said at the beginning, the amount of data in the world is increasing well beyond what the analysts, the paid analysts in IT, the DBAs in IT can handle. And it's absolutely critical that the people who know the business of that organization are able to use data to do their effective work. All companies know this. This is why many of you have actually got a chance to come to New Orleans, which is a fabulous place to visit, to also learn something about working with data. So just understanding the psychovisual analysis a little bit will up your zen with respect to working with data. My first stop is going to be on the get data part. And what I'm going to tell you is that humans are actually pretty wired for working with data. This is a famous writing system that the Sumerians developed in 3000 BC. It's a long time ago. They developed it essentially as a way of keeping records about their commercial transactions of one type or another, along with the writing system, which was pressing into clay, and then once the clay dried, it would be permanent. They also came up with the idea of a zero, and they were able to do mathematical computations along those lines. So that's a long time ago, and it's clear that humans are very wired for working with data, and we're also wired for building different representations for working with data. So here's an example of using maps to actually do wayfinding. There was one of the earliest map projections that was developed was called the Mercator projection. There are lots of other map projections that are useful for lots of other things, but the Mercator projection has this really amazing property, which is that if you draw lines on it, like from where you are to where you want to go, it tells you precisely which direction you should head to go there. Now, you might not be able to get there, but of course, then you can draw multiple lines to get around the islands if you're sailing or whatnot. We're good at developing these kind of external representations that allow us to think using data very effectively. Now, the deep point is that data describes the world. Humans understand the world pretty well, and this gives everyone in your organization the chance to be able to use data effectively in their jobs. And so the way I'm illustrating that here is I took a little snippet out of either this bird strike or the flights table. I don't remember which I took it from. It's small enough that you just can't tell which one. And so this data here maps to either flights or strikes. And the key thing is that we understand, so this is the semantics of that row of data. Once you understand what that row of data maps to, you can take the knowledge about the world and map it back to the data computations that you can direct by the drag and drop or whatever, so that the computer can do data computations for you, and then you map it in the other direction for implications about what you want to do in the world. So the semantics or the meaning of the data is a key thing, and it just taps that fundamental understanding that people have. So the reality of it is you spend a lot of time working with the data, but once you have this sense, you get a sense of how you're trying to proceed forward. The second stop is the view data part. And I'm going to talk about 5 different things with respect to view data that is really important. Incremental, expressive, unified, direct, and effective. And these are why, if you have the right sort of technology, you can actually really work very effectively with data and explore different ideas. The incremental one is, you've already seen it in the demo. It's that drag and drop experience where just like I incrementally start exploring my data, and I go from simple to more complicated as I'm diving down into it, as I'm understanding the data and exploring it. Now, this is really valuable. Anytime you come to a new data set, you can start simple. If you're actually a Tableau newbie in the room, which there can be here in this particular lecture, because it's a general talk, this is actually the journey that you're going to go on. It's an incremental process of diving in deeper and deeper. There's more and more that you can do with data over time. And I like to tell the story about Tom Walker, who was our Tableau's first CFO, but before that, he was one of our first customers. And I remember when he came to Tableau, and he's a numbers guy, right? He's an accountant, essentially. Well, he's more than an accountant. I'll get in trouble with Tom if I just call him accountant. But the first thing he did was he replicated the crosstabs that he was used to using for understanding his, businesses and what they were doing. And then it took him like months to figure out, I could make the data more visual. And once the data started being visual, he realized, but if I change what metric I'm computing, I can get power on that. I can be more persuasive about my company. And then we're now 14 years into the journey, and we're still changing our metrics and computing new things along like that. So incremental is not just a journey of the moment, but it's also a journey of a career, and it can have a big impact on the organization. Expressive. Now, back when I was in the research world, there still are a few people, there were a lot of people who were trying to find the magical view that would do everything, the holy grail view. But the problem is there is no single view for all tasks and all data, and you've already experienced that here in just my bird strike demo. There are different types of views that are useful for different tasks, micro tasks of your analytical work. So here on the top here, maps are really good for giving your data a spatial context for what you want to work in. Trend lines are really good for temporal analytic questions. Tables are really good. Sometimes you need to know the precise number of something. So a table is a perfectly lovely view to use when you want to get those precise answers. And then you really want an expressive environment, because we don't actually know all the ins and outs of all the different questions that people can ask. The one on the bottom is called a box and whisker diagram, a particularly pretty one. It's about data distribution, and it gives you an ability to see the distributions of data over time. It's a favorite view of people who've had some statistics training to be able to go explore different things. So it's actually important to have an expressive set of tools at your hands that you can quickly move through. Like, you might have started thinking you were doing spatial analytics, but then all of a sudden you want to switch to a temporal analytics question. And so you need to be able to move really, really quickly between them. And that's part of what we're trying to do at Tableau. Unified. So a lot of the world is still doing traditional reporting. And the idea there was the IT department would using SQL or whatever, would do really powerful work with a database, and they would generate reports. They'd author reports that they would send out into their organization to empower the organization. And 15, 20 years ago, that was a huge advance for companies, but lots of people are still doing that. The problem, those reports do have graphics in them, so they are tapping your visual system. But the big problem with traditional reporting is that if you get a report for a question you have at the moment that doesn't happen to have what you need in to answer that question, you have to send a change request back to IT. And it'll take weeks, if you're lucky, that they will even respond to your change request for the report to be updated. And at the pace of change in the world today, that delay can be absolutely critical in terms of being able to answer questions. Traditional visualization tools like what I used to work in back when I was a graduate student are really great, highly interactive, cool interfaces, but you still had to pour the data into it. And what Tableau, the advance from the PhD dissertation for Tableau was a domain-specific language that allows us to write queries on the fly to the database, essentially merging the database and the visual analytics experiences together into a single environment. And now you can do that rapid exploration of both of those. And the other advantage of unification is that as the data computation technology continues to advance, so like multiprocessor technology or other technologies like that, Tableau provides that rich human experience on top of it that can be working on increasing amounts of data at the same time. And as I told you, the amount of data in the world is increasing significantly. So there's an endless journey here with respect to data volumes and performance that we're all on together. Direct. So the idea behind direct is to provide these experiences like filtering on the tooltip or clicking on marks, or today in Devs on Stage, you saw both parameter actions and set actions. Set actions is just amazing. And that is, creating these really, really direct experiences. And part of what we're on a journey to doing is we want to be able to have really direct interaction with your data, even on a phone, but the data might be so massive it needs to be off on a server where the data computation happens. And so this is a big engineering challenge that the dev team loves engineering challenges, so it's one that we're working on. And so this is a long journey for us to create these, not just the experiences of directness, but also the underlying computations that support them as well. And then finally, effective. I thought let me do this, and then I'll put a parenthetical remark on it. This is a slide that describes sort of putting data on top of a map. And of course, one of the advantages of putting data on a map is you can sort of instantly get context. Anybody know where that is? Manhattan, yes. This is from the 2008 presidential election. Obama on the left in blue, and McCain on the right in red, contribution data. And so normally in Manhattan, a Republican should get more contributions than the Democrat, but there was clearly a problem for Mr. McCain in the 2008 election. But what I want you to notice is that the road system of this particular map has been muted out so that the data, the circles, pops to the front. This is a fundamental part of what we try to do in Tableau, is always put your data, which is what you're working with, on the front. We literally had to go to map cartographers and get specialized map rendered. And the parenthetical remark I was going to add was, of course, in the keynote this morning, there was the really cool vector maps and whatnot that were really bright and beautiful. You'll want to dial them down if you're going to actually do data analytics. But for certain reasons, for certain times, I thought the satellite map was really, really good. Anyway, normally don't make that comment, but it fits today into this particular talk. So here's a couple of aspects of effective. What you want to do is communicate all of the relevant data. And so I have 3 views here. 2 of them I've labeled bad, and 1 of them I've labeled good. And so starting on the left with the stacked bar chart, I'm not saying stacked bar charts are bad. They're really actually quite useful views in general, particularly for seeing parts of whole. But for the particular task I had in mind, I labeled it bad, which is to say the orange bars here, I'm trying to compare them against each other. This is the eastern region. And the problem is, of course, because of the stacking, those bars are all shifting around, and it makes them hard to compare. In the middle, the dot plot is better because all those dots, the orange dots, are all on the same axis together, so they're easy to compare, but it doesn't communicate all the relevant data because on the bottom axis here is months, it's time. And so the line chart is the best view. It is a good view because we have this standard convention of having, for when time is on the horizontal, to use lines to be able to see the trend lines of that. So Tableau actually has a bunch of rules built in it for trying to do these sorts of best practices. Now, obviously, I use Tableau to make the other ones because sometimes there's a reason to overrule the defaulting of Tableau for whatever reason you have. Here's another one. This is, you want to leverage your visual system. So this is like sample coffee chain. The vertical axis here is profit. The horizontal axis is sum of sales. And then there are 4 markets, either encoded on size or encoded on color. And so the size encoding is bad for a couple of reasons, actually. One of them is we inherently see size encoding as an ordered encoding, and there is no particular ordering to the markets. And the second problem is it can be difficult to pick out a particular market and look at those values using size. You have to scan around and do that. The reason why the color encoding for market is good is because of perceptual popout, what I talked about before. So like, for example, if you look at central, the blue dots, you can instantly see those blue dots are all in a line against each other. And if you want to look at the red dots or green dots or whatnot, you can just direct your pre-attentive visual system to be able to do that. And you can explore that. So my final place to go is on the act place. And I have 2 parts here. And yeah, we're definitely going to give you time to get to lunch, which will be good. There are 2 parts here. The first part is developing an insight. Now, when you have an insight, I talked about this at the beginning, you need to go off and explain your insight to people. And we use an aspirational term for that of storytelling. And the reason why storytelling is relevant is what you need to be able to do is connect your insight and the data underlying it to the world. And when you do that, you can create that emotional connection for the people that you're trying to communicate the insight to. This, by the way, is something that analysts do, highly trained analysts, data scientists, when they're answering questions that an organization may be asking them. But if you have easy enough tools, I call this citizen analysts. Everyone can come up with insights and share them with various people of one type or another. And the reason for that is that storytelling is actually one of the fundamental things about humankind. This is my dad sitting in front of a fire where we've shared many, many stories together. It's something that we just do. Humans just do this all the time. And we can be totally inspired by amazing storytellers of one type or another. I recommend Tableau Public. Even more, I recommend Hans Rosling. And Hans Rosling, his son-in-law, his son and his daughter-in-law just published a new book. Hans died last year, but the book came out. This is, by the way, him talking at a Tableau conference in London a few years ago. He essentially told the same story most of his career. It grew out of his experience as a Swedish doctor working in Africa on disease. And he realized that the world did not understand that it had typecast Africa into just being a poor place, and nothing could be done about it. But of course, he was talking about there are rich people in Africa too. There is really no gap between the rich and poor people. And so he developed some really amazing data storytelling techniques to sort of collect the data, explain the various findings about that. The book Factfulness I strongly recommend to all of you. This is a book that is Bill Gates' top book that he's ever recommended. In fact, he's given it to all college students this year when it came out. My wife and I read this book, and we decided to give it to our entire family. What's so interesting about the book is twofold. One fold is you'll get a description about the basic knowledge about how the world really is. Like, for example, the book has also various lessons Hans learned about why people have trouble understanding the stories that data tells, the stories that he was telling. Like, for example, humans are, we can remember really exciting, often negative events, but it's very hard for us to remember the slow, gradual improvements that the data actually has in it. So you have to go do a little bit of extra work when you're trying to explain some finding, particularly on the positive side, to help people understand the impact of that. He tells, in the book, he writes about going to the World Bank and giving his standard lecture. And it's a significant lecture for the World Bank because there's going to be really huge growth in Asia, in the population in Asia, and a fair amount of growth in Africa as well, which means that for a bank, investment in those two parts of the world are really significant. And it was very difficult for the people he was talking to understand the implications about it. He had to come back and do it multiple times. So the value for reading Factfulness is that it can make you a much more effective storyteller because you can learn what things keep people from really understanding the lessons that there are in data. So the other half of this one, on ACT, is what I call a citizen author. If you've actually done the work to, you're focusing on some task, you figured out what the right data is to address that task, and you figured out what the right views are to do that task, well, you can combine those all together and author a little analytical application that you can share with your colleagues so that they don't have to go through all that discovery process. And as you've seen, of course, today, you can also add extensions to it and plug it into your entire corporate workflow. And so we're seeing a lot of that. A Tableau dashboard can be an explanation of a finding, but it could also be a little analytical application that people are going to use to work with. So as either a citizen analyst or author, just keep in mind what you're trying to accomplish, and then use your colleagues to get feedback on your work, and you'll become much more effective. Like, that feedback is by far the most effective thing for getting more skilled at things. So that brings me to the end of the talk. Thank you very much for your attention. And of course, I came back to the lion, and I started with the lion about bias and how bias is really important and the value of data for that. But I want to make another final point with this, which is that as you're exploring around in the data and you see something that surprises you, sometimes it can be a dangerous thing that you need to avoid, but sometimes it can lead to inspiration, new insights. So data can also be a source of innovation and creativity. And so that's why you should try and work with data all the time. And I've ended early. Please go into your evaluation sections. I only get to give these talks because of positive evaluations. If your evaluation section is completely blank, like mine was yesterday, it's because the app signed me out and I had to sign back in again. So I talked to one person today about that. And I'm perfectly willing to answer questions in public, or you can come up and ask me questions. And I do understand that people want to go get lunch, so don't feel bad about leaving right now if you want to leave. Thank you very much.